All right, so I sent you out an announcement. I don't know how many of you guys ever checked your Canvas, but there are 2 Lab A-led study groups that are meeting on the 2 different campuses if you guys want to go. Basically, the Lab aides are there, and they're not just there to lead a study group about lab, but they also represent most of the lecture instructors. So for instance, a lot of those guys made A's in my class, and they will not only share lab study techniques with you, they'll also share lecture study techniques, and some of them have like amazing study tools that they've developed, and they're going to be there to lead study groups. So there's one, Redwood on Thursdays, 2:30 to 4:30, and Jordan on Tuesdays, 6 to 8. And this one is in the library here, okay? And then they just started this weekend, and I think it's really cool. It's the first time they've ever done this. The lab aides started this Facebook anatomy study group. And I know a lot of you youngsters don't do Facebook very much. I'm trying to get them to do maybe an Instagram one, but you can't put very much text on Instagram, which means it's a little hard to communicate that way. So this is really cool, and there's 27 members now. And so Amanda's running it so far. She's one of the lab aides. What she is doing is she is, for instance, putting up study skills and also quiz questions. So you're supposed to answer here, and then if you have trouble, you can ask them. You can say, I don't understand how you can tell this is this. So far, just over the weekend, she put up quizzes for anatomical terms, quizzes for axial skeleton, appendicular skeleton, and then there's a long histology quiz right here that you can answer, and the lab aides will go back and check to make sure that you actually did it correctly. And in addition, she is also doing live study tutoring sessions online. Today there is one 3:30 to 4, and she is going to go through at that time live, and you can type in questions. She's going to do axial skeleton, appendicular skeleton, and integumentary system. So for those of you who have trouble coming to open lab, I've had people say, I can't come to any of those open labs. First of all, BS, because they go from like 6:30 in the morning until 10 in the evening and on Saturday. So if it was a priority, you could probably make it happen. But let's say you didn't want to drive from wherever you live in Egypt. This is another tool for you, right? So this is there for you, and you guys can join it. And the lab aides are running it, but I'm like popping in just to make sure that nothing's incorrect, right? So that's there for you, and they started that for you over the weekend. The lab aides all have to do a project over the course of the semester, and this was her idea for the project. So, and
so is it only her that's doing it, or someone else doing it?
The other lab aides are in there. She's running it so far. This is that we took that this weekend. Is that not the cutest damn thing you've ever seen in the history of the world? That's Superfly. He's cuter than Tissues, but we're gonna do Tissues today anyway. Superfly. Does anybody know where that reference is from? No? No Weird Al fans. No Weird Al fans. What? No, Superfly is from Albuquerque, that Weird Al song, which is our family song. It's our family song. I know. So you hate tissues? Here's a puppy. If you hate puppies, I don't know what to tell you. You're doing life wrong. Okay. So things to come. You have a quiz the next time I see you. It's not going to be easy. It's going to be histology. As thorough as I can possibly make it. You should not leave here feeling good about yourself unless you have studied your butt off, right? Because you want hard quizzes before tests, don't you? Okay. So you're supposed to have a test a week from Wednesday. That would be the soonest that it is, but considering like these Mondays have knocked us out, we may move it to the following Monday. It would cover the same material, and we would not take Wednesday off. It would just give you a little more time to like absorb the material before you had a test over it. Does that make sense? Okay, so let's see. Tissues, I think where we were doing connective tissues, and I think we just went through the general categories of cells, right? The site, blast, and clast. Is that what we did? Okay, so now what we have to do is just go through the matrix and talk about the types of fibers, and then we'll start going through all of the connective tissues. Good? Does that sound? Okay. All right. So before we get into the specifics about connective tissues, whenever you are looking at a connective tissue, there are three basic things that you have to identify. Again, the cells, right? The fibers, and the stuff that isn't cells or fibers, which is called ground substance, right? So in this tissue, the ground substance is like, usually it stains a little brighter because it has a little less stuff in it. So the ground substance is here, and the fibers, and then of course the cells. So when we get to the fibers, there's three possible fibers that you can run into in connective tissues, and they can be present in any orientation, any number, and any combination. So if you have a long, relatively thick fiber that doesn't branch, collagen. Collagen's function is strength. It's resisting gravity. The metaphor that I use for collagen is that collagen is like the fibers that make up a rope. An individual fiber is not very strong, but once you start to bundle them together, you can get a lot of strength. But they don't have stretch, do they? A rope is not stretchy. Yes? Okay. So they are strong, and if you bundle them all parallel, then they're just strong in this direction. But you can also use rope fibers to make a net, right? And then they're strong in a bunch of different directions, right? So collagen is these really strong fibers. They are the most abundant protein in the body. So there's anywhere, people can't decide, but there's anywhere between 30,000 different proteins and 100,000 different proteins, probably closer to 30. But regardless, 25 to 46% of them are all of this protein. So it's by far the most abundant protein in the body. And collagen is supposed to help you resist gravity and help strap things to other things. And as the aging process goes on, your collagen breaks down because gravity is nothing if not persistent, right? It's like I said, yank, I said, yank. So everything was nice and perky in your 20s. You just wait. Once you put some sunscreen on, it's going to start in your late 20s, and everything's going to start sagging, right? Here, gentlemen, don't think we don't notice. They sag down there too. Everything starts heading south as your collagen breaks down. There are things that you can do that make it less likely that you have collagen breakdown, and there are things that you can do that make it more likely that you have collagen breakdown. Smoking is a good way to start looking like you're 40 when you're 25. Tanning is another good way. Collagen fibers are strong. They're able to resist stress. They don't usually branch, and they often are bundled, and we're going to look at those today. The other types of fibers are elastic fibers. They're made of the protein elastin, and they tend to be thinner, and they can branch. So here's an elastic fiber. They're much thinner, and they usually stain darker, like blue, purple, or black. Elastic fibers, the metaphor that I want to use for those is like those little rubber band elastics, right? Individually, they're not particularly strong, and they have a lot of stretch, but you could make strength with elastic fibers if you bundled them, couldn't you? Right? They would have strength, but they would have a little give to them. So these can be strong while still being stretchy if you bundle them. So those are elastic fibers, and they often branch, as I mentioned. They're springy and flexible. They're not as strong as collagen. And then the last fiber are the ones that you don't see very often. They're present more often than you see them. And that's these. These are reticular fibers. So if this is a rope fiber, this is a rubber band elastic, and this is a hairnet. Okay? So what reticular fibers are is they're also made of collagen, but if you take an individual little rope fiber and pull it apart even further, so you've got those little teeny fibers, and you use those to make a hairnet, that's what a reticular fiber is. It's not particularly strong. You don't really bundle them, but what they can do is they can hold the sort of structural framework for a squishy organ, like a spleen or a liver, right? Just like a hairnet does, right, for the hair, right? So they have a lot of give to them. They hold a loose framework. They're not particularly strong. Now, you don't see them stained very often because they're so tiny. It's difficult to stain them. So they're present in several tissues, but you only really label them in one, which is what tissue? Reticular connective tissue, yeah? Okay, so, and then what about the stuff that is not cells and not fibers? Ground substance, right? Ground substance is so general that you have no idea what's in there unless you are specific about the tissue. Because if you're looking at blood, then the ground substance is about 90% water. If you're looking at bone, it's mostly calcium crystals, right? But if you're looking at cartilage, it's going to be some proteins and sugars that are in there. So ground substance is really this stuff that is not cells and not fibers, that is variable between tissues. So the ground substance is highly variable, big proteins, lots of fluid. And as you change levels of fluid, the tissue gets more squishy or more solid, basically. Okay, so now we are going to get into the specifics of the tissues. Okay, so you guys remember last time we talked about why the heck tissues that are as variable as bone and blood are all considered connective tissues. Well, it's because they're all originated from this one tissue called mesenchyme. I never ask this slide because I don't think it looks like anything. It's like such a, I mean, you can tell it's not epithelial tissue, but beyond that, you're like, I don't know what the hell I'm looking at. I can't even, like, they say this is fiber. I don't even see a fiber there. Like, what the hell are they talking about? So this tissue, I would never ask you from a histology slide. But it is functionally important because what it is the embryonic tissue from which all connective tissues come. It's called mesenchyme. There's also another one that's called mucous connective tissue, but mesenchyme is what we'll focus on. All connective tissues come from this tissue, and like I mentioned last time, you don't have this tissue anymore as an adult or even as like post-fetus, but what you still do is you have a few of the cells left behind, and that's important because these cells function as connective tissue stem cells that if you damaged a connective tissue, they could make a few of the cells for repair. Do they repair everything? No, because there's not enough of them to do that. But if you damaged cartilage and you had a little bit of repair, it was probably helped by these cells. So you do see them every once in a while. You don't have to label them in any of your tissues. But I'm going to tell you that typically mesenchymal cells, which are these connective tissue stem cells, they hang out around blood vessels. And if they get an indication that this tissue was damaged, they'll go, oh, okay, I know how to make a fibroblast, or in a different tissue, a chondrocyte or an osteocyte. And then they'll help you by making a few of those, okay? They don't do complete repair or anything. So they still hang out, and they have the capacity to make only connective tissue cells. And so they're called multipotent. So if you have an embryonic stem cell that can make any tissue in the body, it's called pluripotent. It can make anything. But if it can make many things but not everything, like it can't make nervous tissue, it can't make epithelial tissue, it can't make cardiac muscle, right? Then it's called multipotent. So now let's get into the adult connective tissues that you've been doing in lab, and you either got quizzed on them today or you got quizzed on them last week. Okay, so we are going to work on this, okay, just like we were starting last time. And we are going to do connective tissue proper and then supporting and then fluid connective tissue. For me, you not only need to be able to name the connective tissue and the structures of it, you also need to be able to figure out where it fits into the story. Why do I force you to do that? Because if you have the organization, then sometimes when you almost remember something but you can't quite pull it up, you can say, I can't remember the name of it, but I know it was like here and related to that, and then you can pull it up. So organization helps you to take short-term recall and put it into long-term recall. And I'm an organization junkie when it comes to knowledge. So we're going to start with connective tissue proper. Of the three, this is the most fluid, this is the least fluid. These are the squishy ones that are in between, okay? So they're not like bone and cartilage. They're more like fat and ligaments and tendons, yeah? Okay, so the connective tissue proper is further subdivided, and we talked about this last time at the end, into the loose connective tissue and the dense. And I know you know, but verbalize it for me. What is the basis of this separation, loose versus dense?
How much space?
What?
How much space there are between cells?
How much space?
Ground substance.
How much ground substance versus the amount of fibers, right? So a dense connective tissue proper, the matrix would almost be completely packed with fibers. Very little visible anything else but fibers, right? And a loose connective tissue would probably have fibers visible, but yeah, some spaces that were not filled with fibers. Does that make sense? Okay, so there are 3 loose and 3 dense, and we're going to learn those. So let's start with this one right here. This is a just stylized diagram of this tissue, which is areolar. or quite often I call it loose areolar. Areola means space. Areola means space. It's got an open spaces. So loose areolar connective tissue is this one right here. This is a tissue that if you don't memorize any other tissue, you better memorize this one. They're so easy to ask questions from it because it's got visible fibers of both types. You can always see the ground substance, right? You can always ask whether it's loose or dense and then where it fits into the categories. So this is a tissue that you should be really familiar with. So let's talk about it. Talk about what you need to know about it. All right. So loose areolar connective tissue contains all three types of fibers in the matrix. So it has collagen, it has elastic, it has reticular, but the reticular don't stain, so you don't have to label them. Does that mean you're not responsible for knowing that they're there? You are responsible for knowing that they're there. So what does that mean? That means it has a little stretch to it. It's this tissue that if you pull up on your skin right here, someplace that you don't have much subcutaneous fat, like your forearm, it gives a little bit, but it also has a little bit of snapback, right? And it has a little bit of loose structure, like a hairnet's holding it together, right? But it's also got some strength. It'll actually resist and is not going to pop off, right? This tissue you have encountered if you have ever skinned anything. Whether it's a human or a chicken or a fish or a deer, doesn't make any difference. There is a natural separation which when you pull on the skin will let go and separate the skin from the muscle. And if you pull it up, you can actually see the fibers popping. Little bitty silver fibers. Have you guys ever skinned anything? You should totally skin something if you haven't, right? Even if it's just a chicken. Pull it off and look at it in there. That's a loose areolar connective tissue. And you were actually seeing those fibers break. So let's see what else is in there that you could ask. This is a tissue that is found so many places. If you didn't know what to put under any epithelial tissue, it's probably this one. So it's under like your mucous membranes, it's under your nerves, it's like surrounding the muscle, attaching it to another muscle. It is the glue of the human body. It's found all over the place. It has all three kinds of fibers. It's soft and pliable. It has mostly fibroblast cells because there's lots of fibers, right? But it's also got all kinds of other cells in there. You don't have to label these other cells, but let me go ahead and tell you that also in addition to the fibroblasts that you see here, you're probably seeing a bunch of other cells. White blood cells migrate into this tissue. It's a really good place to put a sentinel if it's right under an epithelial tissue, right? You also have potentially mesenchymal cells hanging out there, fibroblasts, like we said. So there's lots of other kinds of cells in this tissue. You do not have to label in this tissue anything but a fibroblast. But FYI, you don't actually know that that's a fibroblast, do you? You're just like labeling it that because that's what you memorize. So it's a bit of a fib for you to like point to a cell in this tissue and call it fibroblast, but it's fine, I'll let you fib at this point. So in addition, this tissue, of course, has readily visible collagen fibers that you should be able to label, right? And they are unbranched and thicker, right? And readily visible elastic fibers. And then not readily visible reticular fibers. They're all present in this tissue. Okay, so let's look at a couple more pictures. This is also the same tissue. Please note that you do not want to get dependent on color for identification because there are a bunch of different staining techniques. And this is still recognizable as the same tissue. If you just give yourself the opportunity to compare it to other tissues, then you'll be like, oh, I got it. I can see it. Okay, so let's look at another iteration of this. So let's answer these three questions. Let's pretend that this was a quiz question, and I say, name the structure at number 1. You would say, elastic fiber. Name the structure at number 2. Collagen fibers. Name the structure at number 3. Fibroblast. What's this? Ground substance. What general category of connective tissue is this? It is connective tissue proper, and then it is loose connective tissue. Good, you got it. And then the only question that most students are prepared for is probably the last one I would ask you about this tissue, which is name the tissue. Areolar, or areolar if you want to call it, or you can call it loose areolar if you want to. Go ahead.
For it, would you rather say connective tissue proper or loose connective tissue?
I would make that a multiple choice question. You would have to choose the most correct answer.
So can you review, so the general
connective tissue proper,
And then the
supporting, and then fluid. And of the connective tissues proper, is it loose or dense? So that would probably be two separate questions. Hmm?
that one a little fast. All right. So connective tissue is the general, and then
Mhm.
the loose connective tissue is
Loose. Fewer fibers.
right. Oh, okay.
Fewer fibers. So it would be two separate questions, right?
But what's okay? So connective tissue proper is the general,
Yes.
and then loose versus dense would be.
Is this a loose or a dense connective tissue?
So it doesn't
Proper.
have a category name.
Not really. Mm-mm.
Okay.
Is this a loose or a dense? And again, remember, I'm not terrible at writing questions, I promise. I'm pretty good at writing questions. And why? I get good at it because students bitch when I'm bad at it. So that's a good motivation for me, right? Right? So then eventually, unless you want to argue with students about every damn question, you think about your questions very carefully because otherwise you are going to hate your office hours. That's a decent motivation for me, isn't it? Yeah. So,
And there's those examples right here.
yeah, there's examples too.
Like, right
But
here.
yeah, I understand what you're saying. Like, how would that question be worded? I don't know. I haven't written it yet, but I'll be careful when I word it. Okay? Good? Okay. So, you guys okay with Areolar? Yes? Multiple questions you could ask about that. I can always think of a question for Areolar, so it's usually got more than one quiz question on there because, like, if I can't come up, like, oh, I wonder what I'm going to ask. This one has, like, every kind of question you could ask about it. Okay, so make sure you study that one. All right, so now I want you to look back here real quick, and I'm going to show you something that seems counterintuitive initially. Okay, the next tissue that we are going to talk about is going to be adipose. And adipose does not look like the other connective tissues, like you can't see the fibers and stuff. So I want you to listen to how you get adipose so that you can figure out why it fits into this category. Ready? Okay, so the same place that you have loose areolar connective tissue right here, yeah, is the place that you will get adipose when you start gaining weight, right? It's the same place, yeah? So what happens is as you start to gain weight, you will motivate these cells, which are always potentially present in loose areolar connective tissue, to go through multiple rounds of cell division, right? And what ends up happening is you had the structure of an areolar connective tissue that then filled up with storage cells called adipocytes. And then by the time you get done, it doesn't look like this anymore because it is basically areolar connective tissue plus. And areolar connective tissue plus what? Well, let me show you. So let's say it started out loose areolar, right? And we had a bunch of fibers of different kinds, and we had fibroblasts and other crap in here, right? But then you hit 30, and you eat exactly the same way that you used to, and you do exactly the same level of exercise, and what happens? What happens, people? You start gaining weight because the world is rude. Right when you have the money to afford the things you want to eat, you can't eat them. So what happens is you start going through cell division, yes? And you start filling up this tissue and pushing everything aside, yeah? And you start going through cell division with these adipocytes. And each of the adipocytes, they're so big, and they're mostly lipid, which doesn't stain with water-soluble staining techniques. So by the time you get it full, it doesn't look like it has all that other stuff in there because they're all smashed between the adipocytes. Do you see? And it looks like chicken wire. So what you are actually seeing here is each of these little guys that you're seeing is a cell with just the nucleus pushed all the way up against the side. And most of it doesn't stain at all because most of it is lipid. What is filling this cell? What's that called? A lipid vacuole, right? It's just a big drop of oil. And if you use a water-soluble staining technique, the lipid vacuoles won't stain at all. And you'll just every once in a while see a nucleus on the side. Now, are there fibers in there? Yeah. Are there other kinds of cells in there? Yep. But they are crowded out by the adipocytes. Does that make sense? Okay. So that's why this tissue that doesn't actually look like a loose connective tissue is a loose connective tissue, yeah? Because it started out like that, and then you got fat. Does that make sense? And it's why it's in the same place that you have your loose areolar connective tissue. Okay, what was your question?
So is that why when there's, I don't know, a big weight loss in someone that their skin is kind of like,
Yes.
you have excess skin and
You have excess skin, especially if you're really young and you lose weight, then a lot of times you'll have enough elasticity in your skin that it'll snap back. But if you lose weight in your 30s, 40s, 50s, and 60s, you don't have as much elasticity to your skin, and that it's just going to stay flappy like that later.
So those are just connecting it. That's the lipid vacuole is like leaving, right? So
Yeah, we're going to talk about gaining and losing weight in just a second. So good. Okay.
So is the whole circle of the adipocyte and
Yes,
then the
good.
middle is the lipid vacuole?
Yes. Okay, so the whole cell, guys, is what? The adipocyte. Yes? And then the thing in the middle. So how would you ask this? Well, it depends again on me asking the question carefully. So let's just go down to here. Okay. So if I point to here with number 1 and I say, name this cell, then the answer is adipocyte. And I say, name this structure or organelle, then it is a lipid vacuole, right? That makes sense? Do you see how this ends up looking like this? It doesn't look like much of anything. It looks like chicken wire to me. So here it is up close, right? Here it is a little further away. Here it is when this poor little person is getting fat. Look at all these little baby adipocytes you made. What motivates you to go through adipogenesis, making more adipocytes? What motivates you to go through adipogenesis is that you take in more nutrients than you can store by any other mechanism, and you're not burning them off. So what happens over the course of multiple days is if, for instance, I take in, let's say, so much glucose, so much sugar, and I store as much as I can in my liver as glycogen, then I still have extra. What do I do with it? I make it into fat and store it up for a rainy day, right there, right? The problem is that when I do that the next day, I continue to motivate these to go through adipogenesis or cell division. And the tragedy of adipogenesis is although that you can see that this would be a tremendously beneficial evolutionary feature to store energy when you have excess, right? Now in this particular era of evolution, in Western civilization, our problem is generally not resources, that we don't have adequate amounts of resources. Is that we have so much calorically dense food available and such low levels of activity that we do so much of this so quickly and so readily. And then the problem is that evolutionarily, there's really no way to get rid of these cells once you make them. So what happens is once you do that, you start making you make more storage places, right? Okay? And when you make more storage places, then it's easier to store the next time, right? The problem is that you can't get rid of them. Like once you have gone through adipogenesis, once you have made fat cells, they are there, and they are easy to fill up the next time. So let's think about this. The first time you get fat, it's a shock. You're like, what the hell happened, right? But then the next time, how easy is it to get fat after you lost weight? Oh, it's totally easy. It's like the default, right? And why? Because when you, as she asked, when you lose weight, what you do is you empty out the lipid vacuole and burn it for nutrients, right? Okay. But then you still have it. So it's easier to fill a storage vesicle that you already have than to make them the first time. Does that make sense? Okay. So this matters for those of us who are parents because chubby toddlers are fine. They are supposed to be chubby. Okay. Chubby teenagers are going to have weight problems throughout their entire lives, right? And why do teenagers get chubby before they're 16 and can drive themselves? Because you buy chubby making food for them. That's why. And you don't make them wiggle it off or encourage them to wiggle it off. Here's the soda. Run to the soda. Run. You're like hanging on top of their scooter. Go get it. Doesn't work at all. Teenagers are very difficult to manipulate. I've got an 18-year-old. He told me I was manipulative the other day because I gave him something and then I wouldn't actually let go of it until he said thank you. He's like, you're so manipulative. And I was like, what? I literally just bought you a present. And he's like, you're so manipulative. I'm taking it back, you little bastard. He's not a bastard. He was acting like a bastard. Okay. All right, so this is adipose. And adipose is, the cells are adipocytes. One of the other things about adipose is that typically when you have adipose laid down, it doesn't lay down on a nice, even layer. It lays down in little lumps. And if you have relatively thin skin, genetically, or as you age, then your skin will follow the lobules or lumps. And then you have cellulite. Yeah. And cellulite has a certain genetic predisposition to it. Yeah? So you're more likely to get cellulite if you have parents that have cellulite. Why do women tend to have more cellulite than men? Well, women tend to have more fat than men. Like our body fat range is higher than a healthy man's body fat range. In addition, we're not as furry, so you can see it. If you just let your legs get super hairy, nobody would ever notice. But you know, you have to weigh out the consequences of both things, right? So how do you get rid of adipocytes? The only real way that you can do it is liposuction. And liposuction is really not a solution because liposuction is not global. You can't just like stick in the cannula and like suck it out everywhere. You have to be localized about it, right? You pull it out of some little local area. And then when you pull it out of the local area, then what happens is the next time you gain weight, you will gain weight other places first. So what it changes is your body fat deposition. It doesn't make you less likely to gain weight. It makes you gain weight differently the next time you gain it. So first of all, adipose is really vascular. Have you guys ever seen liposuction on TV? Totally watch it. It'll make you like put down the donut. You're like, is it donuts or this? Because that looks terrible. It's super vascular. There's a lot of bleeding that goes on with liposuction. So you can suck out the adipose with liposuction, but you can only suck it out locally. And what they do is they stick a little cannula in between those two layers, and they like break it up and then suck out the adipose. But my best friend, who I talk about all the time because she does such crazy crap, I love her. She's really good for stories. She had liposuction. She had lost a lot of weight, but she still had these, right? She didn't like them. So she went and got these all sucked out on both sides. And I like told her, I was like, Chelsea, you shouldn't do that. And she got them sucked out. And then as soon as she gained weight after that, because she's in her 30s, what happened is she didn't gain butt weight here. She gained it up here. Now she got a top butt, right? And she's like, I literally like the bottom butt better. And I was like, I tried to tell you it was going to come back. So she basically is gaining weight right here. So what happens when you get liposuction is you tend to gain weight in a different pattern than you used to, but you still gain weight. So, and eventually she keeps trying, she'll also gain a bottom butt, but now she'll have a big old, like it goes from here to here, the butt. What is the function? This is insulating, it's cushioning, it's a major energy reserve. Some places it's cushioning, some places it's insulating, and when you gain subcutaneous fat, it's usually energy reserve that you're going to use for later. It's all well and good when you're trying to store it. It's good for storing energy, but because it's really has a lot of calories per gram, more than proteins and more than carbs, it's hard to get it out when you try to get rid of it. I will tell you just a teeny bit about adipose tissue, leptin, and weight control. So over the last 15 years, they've figured out an awful